Hello, and welcome to Nodes 2020. Thank you for joining us today. I am Ann Beeman of Data Philly. Data Philly is a community-run meetup group founded in 2013. We have almost 5,000 data science practitioners and enthusiasts. We host monthly speaker events and workshops focused on the latest technologies and models in data science. You can follow us on Meetup and Twitter. Even if you live outside of Philadelphia, we invite you to join our virtual events. I'd like to introduce you to our speaker. Sebastian Müller, CTO at WiWorks, will be presenting on bespoke visualization tools for complex data. To give you some background on our speaker, Sebastian has been working in the field of graph and diagram visualization for more than 20 years. He joined WiWorks in 2002, where he works as lead software architect and CTO on the WiFiles diagramming libraries. Thank you and welcome, Sebastian.
Hello everyone, my name is Sebastian. I'm CTO of WiWorks, the diagramming experts. I've been invited by the friendly folks at Neo4j to do this session, but WiWorks is also sponsoring the event, and thus there's a virtual booth that you can go to after my talk to learn more about what we are doing. I'll be there too, to answer remaining questions you may have. I hope that I can give you an idea in this talk about how we can help you with our free and our commercial tools with your visualization projects. Drop by our booth and we can provide you with links to tools around visualizing and understanding Neo4j databases. This is my agenda for this session today. I'll tell you about covidgraph.org. It's a non-profit organization and how they are using graph technology to help fight COVID-19. And you will also learn how to use tools that can help you understand complex Neo4j database schemas and how that knowledge can be used to create custom apps for visualizing the contents in a graph database. I'll be showing no-code solutions, but I will also show you the benefits of writing custom code to create great bespoke visualization apps. To illustrate this, I'm going to show you how we created the Visual Graph Explorer app for the COVID Graph project and what tools we're using to do this. I hope that if you belong to one of the following groups of people, that you will find the session useful. If you're part of a team that is already using or planning to use a graph database and you're specifically interested in ways that help you visualize your data, there should be lots of interesting information in these slides and the demos. You don't have to be a data scientist or engineer, but if you are, there will be something in it for you, as we'll be looking at ways to create software with no and low code solutions. As a project manager working with knowledge graphs or large graph databases, you will gain a better understanding of the options, required efforts, and benefits of using and adding visualization to your GraphDB use cases. And if you're a software developer, you'll be happy to hear that I also have a few slides and samples that deal with software craftsmanship. Let me start by introducing you to the COVID Graph project. As you can probably guess from the name, the project was founded earlier this year in response to the global pandemic situation. It's a collaborative effort of a group of people who were connected through their use of Neo4j in their daily work. You can find more detailed information on the project website, but here's a quick overview. It all started with this call to action that I saw on the social networks earlier this year. Researchers around the world were publishing these huge amounts of research data around COVID-19, coronaviruses, SARS, and so the software development community was asked to help with analyzing the data and making it more accessible to researchers. Usually by the time I stumble upon such interesting data sources, the community teams at Neo4j already had been there and had loaded the data into some Neo4j instance for everyone to play with. But this time I was first, and I couldn't believe that no one seemed to have had the idea to load all of the connected data into a graph database for others to play with and work with. So I used LinkedIn and asked my network for help, and only 3 days later, I had found Martin Preusse from Kaiser & Preusse and Alexander Jarasch from the German Center for Diabetes Research. Both are longtime Neo4j enthusiasts. And Martin was very quick to set up a Neo4j instance that loaded the data, and with Alexander on board, it was easy to connect with his huge Neo4j network so that within weeks we had many of Europe's big players in the Neo4j ecosystem on board and contribute to the project. The team created a build pipeline that loaded the data from the various sources we had gathered into a single Neo4j database. This enabled us to conveniently query publicly available data from those many different sources as one huge connected knowledge graph around the topics of medical publications, patents, biomedical databases, and more. You can find the pipeline on GitHub of the project. It uses orchestrated Docker containers to load the data from external sources, transform and prepare it to load it into the Neo4j database. We created the connections between the data using both simple text matching algorithms as well as natural language processing and named entity resolution algorithms, forming a network of millions of interconnected items. The database is publicly available, and the project also provides a number of apps that connect and query the database. Some of them are accessible for the public directly from the homepage of the project. I'll show you one of these apps later in the talk. The many data sources that contribute to the network result in a pretty complex database schema. As you know, the Neo4j graph database is basically schemaless, but of course the data is structured and can be queried according to its implicit schema. One has to have a good understanding of this schema in order to create a useful app for end users. With all the data sources, the schema of the app grew quickly, and it quickly became necessary for the developers to keep track of the schema and understand the available connections in the data. The first tool everyone is using when given access to an unknown Neo4j database is Neo4j's own Neo4j browser app and the Neo4j desktop. It's great for writing and testing queries and has some visualization capabilities built in. But for non-trivial database schemas, the tool is not powerful enough. When we were working on our graph apps, we had this nifty tool. It's the Data Explorer for Neo4j, and it's a free web application that can be used by anyone working with a Neo4j database. All you have to do is direct your browser to yworks.com/neo4j-explorer. The app is hosted on the yworks.com website, but it's a static web application, meaning that it directly connects from your browser to your database and does not use an intermediate server. This works using the official Neo4j Bolt driver, which is a JavaScript implementation of the so-called Bolt protocol, which allows developers to run queries against the database directly from the browser without going through a separate server. Thus, you don't need to worry about your data leaking outside your organization when using the tool. You can even disconnect from the internet after you started the app and then use the app offline. As long as you can connect to your database, it will work without a connection to the internet. After startup, you give it the connection credentials of the Neo4j database. You will find the credentials for the covidgraph.org project on their site. After connecting with the database, the app starts by parsing the schema of the database. This takes a while for the complex schema of the covidgraph project. But once it's done, you can conveniently browse the schema. And with the different automatic layouts we have, finding a visualization that helps in understanding the structure of the schema is easy. You can look at the various relationships and the nodes, and also what properties are associated with them. You will also find information about full text indices, constraints, etc. One of the central data sources for the covidgraph project is the papers entity. It represents scientific publications and preprints. As you can see, a paper is associated with authors, references, an abstract and an optional body text. These aren't modeled as properties of the paper node. Only properties where there's at most one value is stored with the node itself. Instead, there are typed relationships to other nodes. Let's have a look at one of these connections. In this specific database, papers are connected to hub nodes. For example, the body text collection is a node that connects with all the sections of the full text body of the paper. Each body text node has a number of fragments. There's a specialty in this schema of the covidgraph. There are fragment nodes that represent text fragments within the sections. But some of the labels we have are only used as combinations of node labels. This means that the actual nodes in the database have more than one label. In this case, the fragment label is used in conjunction with one or more of the many from prefixed labels. The Schema Explorer tool allows us to clean up the schema to show us which label combinations are used in what constellations. Let's select all of the fragment labels and then ask the tool to split up these labels. What we get is a much simpler schema. Now the paper connects to a body text collection, which connects to body text, which only connects to one type of fragment. And this is, maybe not so surprisingly, the fragment from body text label combination. From this, there's a mentions relationship to gene symbols. So basically this is a relationship between a paper and the genes that are mentioned in the paper text body. So let's verify this with the help of the other major part of the application, the Explorer. We can switch to Explorer view and choose to start with random nodes or search for some nodes to start our exploration. Let's look for a specific node. We search for a paper with a title that contains, for example, the fragment angio. There are many results and we can use a second level filter to find paper nodes that also mention ACE, which is a gene name. I can choose which elements I want to see in my diagram and then include them in the diagram. Clicking on the node, I can see all of the node details in the property pane on the right. Opening the context menu on the node allows me to iteratively explore the network. I can choose to incrementally load nodes by either their label or by their relationship type. Let's load the body text collection. There is only one. But this one has 24 body text nodes. Let's load a few with ACE again. And from there, we finally get to the mentioned gene symbols. If there are multiple fragments mentioning the gene symbol, we would get to see multiple connections. We have now unrolled the multi-hop relationship between a paper and the genes that it mentions. But wouldn't it be cool to get rid of all the intermediate nodes for the purpose of the visualization and just see the connection between the papers and the genes? Let's go back to the schema. We find the paper node again, and then we create a virtual multi-hop relationship. This does not affect the database and is only used in memory in the app. Via the context menu, we choose Create Transitive Edge. And then we connect the nodes we're interested in. Via body text, the fragment, up to the gene. When done, we finish this step and we get to see a dialog where we can see the cipher query that we implicitly created. We can give our new relationship a name and then go back to the schema. We see our edge has been inserted into the schema view. Now when we go back to the Explorer view, we find the new relationships shown in the diagram. We can now remove the elements in between and only see the new connection we created. Also in the context menu of the node, we now get the option to load all the mentioned genes for a given paper. There are many more genes mentioned in this paper. Unfortunately, by default, the name of the gene is not shown in the visualization. That's because the app uses a heuristic to decide what properties to display initially. And since in the database we're using some unusual property name for the name property of the gene, it's not being displayed. It's SID here. If, however, we want to see the name of the gene in the visualization, we can define a custom visualization template. This can be done on this tab. Here we can select to create a new template. We specify that the template should be applied to all gene symbol nodes, and then we we can edit the template. This editor allows us to add arbitrary static and data-bound images, geometric shapes, and texts, and so on. Let's just add the label to the standard template. For this, we drag a text element onto the editor and position it to our liking. Then we change the static text to a data-bound property. The node properties from the database are stored in tag.properties and then its SID. As you can see, this renders the label from the data on the node. Let's also quickly add some geometric shapes and image and change the color, just for the fun of it. Close the editor, and that's it. There's much more we can do in the Data Explorer, but it will always stay an app that is hosted online and is a generic tool. Now what if we wanted to create our own tool? How difficult would that be? Can we use low-code or even no-code techniques to create a custom application that is specific to our data and for our use cases? We can. At Wireworks, we've been working on another amazing tool recently that allows us to do exactly that. Create a bespoke, graph-powered visualization application without coding. It's also built on top of our graph visualization programming library Y-Files. But the tool allows us to create our first application without even looking at the API or documentation of the library. We don't even need to code. Let's have a look. The app itself is currently in early access and not yet publicly accessible from the internet. It will be soon and it will be available for free for everyone to try and play with. Please talk to our team at our conference booth or contact our team at Wireworks if you want to get early access information for the tool. But let's see how it works. So this is the ETL designer. We can use it to create a data flow and ultimately create a custom application. For the purpose of this demo, let's start with defining a simple JSON string constant. I have some sample JSON data prepared here. That is just a very simple and small JSON structure with an array of nodes and some edges and some properties. So we input that JSON as a string, and we start by transforming it into a JSON object. Then we're going to split up the JSON into two collections. One is the nodes array. The projection node will pick just the collection from the complete structure. And we're going to use another one to pick the edges property. This will give us two separate collections of node and edge objects. Now we need to tell the engine that these are actually used for the creation of nodes and edges respectively. We connect the data with these source objects to enable the creation of the diagram elements. Those node source and edge source objects can then be fed into a graph builder processing node that combines the data and connects it to an in-memory graph structure. In order to finally display the graph, we're going to play an automatic layout algorithm on the graph and then tell the program that this is the result we're actually interested in and that we would like to see in our application. So to make all of this work, we need to configure the data sources and specify which JSON properties identify the elements via their IDs. Edges reference the nodes, in this case via the S and T properties. Now what's left is how the nodes should be rendered in the visualization. I don't like the default for the nodes, which are too small, so here let's specify a larger default size for the nodes. After this, we can already see the nodes represented by rectangles. Let's configure the visualization of the edges too. If we take a closer look at the data, we can see that there's a label property. And we can use that label in the visualization too. We can actually have any number of labels for the nodes and the edges. So let's just add one for the edges. This could be either a static text for all of the nodes and the labels, or a dynamic binding like in this case. Or it could even be a combination or some computed value. Nodes in the JSON also use the label property for declaring their labels, so we can just reuse the one label configuration for the nodes too. So now this gives us labels for both nodes and edges. I ran an automatic layout to clean up here my flow graph. Now we can actually preview what our tiny application will look like at runtime. We just need to hit the play button to see a preview, but the really powerful feature of this application is its ability to pack this application as a source code bundle. We can choose which UI framework we want to use, some options like the component framework. Here in this case it's Vue.js and Vuetify. And we can choose our preferred programming language and add some more out-of-the-box features for our application. The application, the resulting one, will be powered by Wi-Fi's for HTML, the diagramming library. So we also provide the node module package and the version we want to use, as well as the licensing information. So this will ultimately create a zip file with some scaffolded source code that we can then give and bundle and provide it to our end users. Of course, since this is all just source code, we can then use the powerful Wi-Files API to add more features to our simple application. So after we've given it a name and the app has created the project files for us, we can then unzip and load it into our IDE. After building and deploying it, it will render the graph exactly like we've seen it in the preview. I will show you that with the next example though, which will be using Neo4j instead. So let's see how we can load the data from Neo4j via Cypher queries. There's this telling Neo4j loader node that we can use. Of course, we need to provide it with the credentials for our database and all that configuration. Let's go back to the Database Explorer app for Neo4j. The app already knows the credentials and connection properties as we have entered it the last time. And more importantly, it also knows how we want to visualize the elements in the graph. I added custom visualizations for genes and papers already, so let's reuse that. I can simply export the app settings to a JSON file, which we can then import into the ETL tool. I use the option to add it to my local projects. The ETL designer is able to parse the configuration from the settings file and builds a flow graph from it. This is still early work, but nevertheless, here it is. In this version of the tool, I still need to manually run the automatic layout to get a nice overview of the flow graph. Since this wasn't created manually, there are no suitable locations for the nodes in the project. There's an error in the project. The way I exported the settings, it did not contain the password and username, so I need to fix that. And since in this specific case the database runs on an older version of Neo4j, I need to switch to using the bold scheme. After this, we can specify a starting Cypher query that will be run on application startup. I just modified it to load some paper nodes. And when we launch the preview, we can see the papers styled in the way I configured them in the Database Explorer app. The query as such is not very sophisticated though. Let's try the more interesting query about the genes mentioned in papers use case. When we were creating the transitive edge in the Data Explorer app, in the final dialog, we saw the structure of the Cypher query for the transitive relationships. Note that button which allows us to copy the query to the clipboard for use in other tools. I can then just paste that query into the Cypher input field of the ETL app. The query can be arbitrarily complex and I can even parameterize it through the ETL interface. Here I will just modify it to return all of the elements referenced and limit the number of results. This way we actually get a connected graph with a few relationships. And the graph uses the symbols and the data-bound visualizations that we customized in the Data Explorer app. Let's see it. Here it is. And we did all this using no JavaScript or TypeScript code at all. Isn't that cool? Again, let's bundle this as an application. This time, the application bundle will also have the Neo4j driver as a dependency in its package.json file. So this way, all that needs to be done is an npm install or yarn install to get the app up and running. Let's take a look at the package and see how it looks in our IDE. This is the package.json, and this is the dependency to the Neo4j driver. Let's open it in the IDE. I unzipped the zip file, opened it in my IDE, and with the pre-configured package.json file, I was able to install the required modules using yarn. This added the Neo4j bolt driver and the Wi-Fi library to the app. All that is left now to do is to serve the app. So let's do that and see what it does. While it prepares the bundles, let's take a quick look around. This is a Vuetify-powered Vue.js application written with TypeScript, with a simple toolbar, and of course, there's a graph component. By default, there are some actions defined that will be available as buttons in the UI. And let's see it. Wait for it to load, and here is our graph. For fun, I configured the graph to be editable, so that you can see that this is actually an interactive app. I can create new items, relationships, etc., and perform undo, redo, and so on. And since this is all available as a source code, I can use the powerful API of the diagramming library to add more features or change the behavior to suit my exact requirements. For example, in order to apply a different kind of automatic layout. With the Webpack build and the enabled hot reload, the code changes get applied immediately. In this case, since my query only resulted in 3 relationships, this of course does not lead to a very interesting result. But it only took me minutes and literally just 1 line of code to create it. You can imagine that if we invest more time into it, the result will be far more impressive and useful. So this is what we did for the COVID graph project. So this is the COVID graph app that we created. Note that we did not use the ETL tool that I just showed to you, because at that time it wasn't available yet. It uses the same underlying technology though, and actually it is our declared goal that after some work on the generator tool, it will be able to scaffold an application like this too. This tool here also connects directly to the COVID graph database, and was authored using a combination of Vue.js for the UI and Y-files for the diagramming part. Let's see how it works. We added a custom search box to the top of the application, where users can pre-select the type of entities they are looking for. Then you may enter a search query, and depending on the type you are querying, this will either be going to a Neo4j full text index, or it will be using a parameterized cipher query. Once you entered the search string, this will execute the query and fetches the results. If there's more than one item matching the query, we get to see a preview where we can pick the items which we want to see in our diagram. That's very similar to what we had in the generic Data Explorer for Neo4j app. This loads the elements on the screen. We can add more elements on the screen using the queries above. For each node type that we load from the database and visualize on the screen, a separate SVG template was created that shows the most important information to the user right in the visualization. We use level of detail rendering to remove information from the visualization if we zoom out, or add more information when we zoom in or select an item. Additional information is shown in the details panel on the left-hand side for the currently selected item. In contrast to the generic Data Explorer app, this app can show more than just the immediate properties of a node. For example, in the case of the paper, we can see the full text directly in the side panel. We can possibly get a link to the publication, and we also get a preview of some of the associated entities, like the mentioned genes and the authors, which are actually separate entities in the database and in the visualization too. And they can be added to the diagram with a convenient interface. Also, there's this load context menu, which mirrors what's available in the context menu of the diagram for selected elements. Similar to the Data Explorer, we can explore the neighborhood of the element, but this time we're using clear descriptions for the menu entries and only show those entries that are important for the use case the app has been created for. You can also see that we have the transitive relationships again in this app. There are a few powerful queries that you can perform through the app interface. They were built in response to a specific use case and added to the graph, but you will see that they are still relatively generic at their core and can be reused for other apps in just the same way. So let's go through some of them. Let's say as a researcher we have been reading this publication. We have seen that it mentioned these two genes, ACEH and ACE2. We would like to learn more about these genes and find other publications that also mention these genes. If we were to simply look for publications that also mentioned ACE2, we would quickly be lost because there are so many papers talking about this gene. Luckily, we can use the power of graph technology to find publications that mention both of these genes at the same time. In the app, we can actually search for all types of common neighbors if we select one or more items of the same type. And sure enough, it will come up with another paper that mentions both genes, and that we should go and read. Basically, our knowledge graph worked as a recommendation system for us. Here's another slightly more complicated situation. We know that the ANG gene is involved in this pathway, and it's encoded by this protein. Now, if you would like to know which other genes are related to this pathway and at the same time are encoded by that protein at the top, we can select these two elements and find other genes that connect the two other types. Graph technology again helps us find the results. This involves a pretty complex cipher query, which is very difficult to write manually, but it's just 2 clicks in our app and the results are easy to read from the diagram. Now you might think that this requires a lot of complicated coding. It actually doesn't. Let's have a quick look at how some of the features I just demonstrated have been implemented. The application source code is also on GitHub with the COVID graph organization. So if you want to have a look at the sources or even modify them and build your own version, the code is online with build instructions included. For this app, there's quite a lot of code involved and it took us several days to implement it. But you will see that what we've built can be easily adjusted for your own specific use case, because most of the code is very generic and can be put to use in other explorative graph apps just the same. The code that generates the UI and manages the cipher queries, connects to the graph visualization library, etc., can all be reused and you don't need to bother with it. But still, in order to be useful, the app needs to be aware of the schema specific to the database it connects to, in order to provide the answers to use case specific questions quickly. Those parts that deal with the database specific schemas and entities are separate from the rest and can be modified easily. Let's see how this was done. Basically, what the application needs to know is what aspects of the data should be presented to the user and how. We need to teach the app the schema of the diagram. We learned about the schema from the Data Explorer app I showed you previously, and we've seen how we can use the former app to create cipher queries for the more complex multi-hop relationships. Let's see how the entities and their connections in the diagram were declared in code. There's this one central COVID graph loader JavaScript file, which contains all the customizations for the COVID graph schema. It tells the app what entities there are. We need to pass in the Neo4j node labels so that they can be identified in the cipher queries. We also need to specify how the nodes should be visualized in the diagram and at what sizes. For this, we can use the same data-bound templates that we've seen in the other tools, and of course, we can add more to them and use the power of the web platform to create a rich user experience with CSS animations, transitions, and styling, and so on. For a simpler styling, there are more options available here. We can add more text labels on top of the visualization and specify what should be seen on the tooltips when the user hovers over the elements. And for the table preview results you've seen, we specify how the results should be rendered and what columns should be shown on the screen. And should we need to use a more sophisticated cipher query for loading or searching the entities, this can also be specified here. For each different type of entity, one such section needs to be added to the app in this way. Likewise, in order to specify the connections that users should be able to traverse and explore in the visualization, we declare them in a similar manner with a separate method call. Of course, we could use a very simple cipher query to load direct neighbors in the database, but we can also reuse the queries we obtain from the Data Explorer and add conditionals to let the user quickly find those entities and relationships that they are looking for in the data. Again, for the edges in the diagram, we can also add tooltips, style the connections to our liking, adjusting strokes, colors, labels, arrowheads, and so on. This is all that is required to get the automatic search and the filtered result views for exploring the neighborhood of the nodes. And this is actually also all we need to do to also automatically enable the common neighbor search option I just showed. The app assembles the more complex queries from the basic queries we provided here. Then, when the user selects multiple elements, the app will automatically search the schema to find and generate the correct cipher queries to find the mutually connected elements. Lastly, to enable the missing link searches, we only need to specify which pairs of relationships we want to intersect to enable that additional context menu entry. This is what happens in these lines of code. And that's it. So to summarize, by using Wi-Fi's for HTML and by programming, we were able to connect to arbitrary data sources. Even live data sources that push updates to the client are possible. Apply custom automatic layout for the creation of meaningful layouts. Even though in these examples only very simple layout algorithms were used, for other data models and domains, we could be using much more sophisticated automatic layouts that encode information that the end user is interested in directly into the diagram. Also, we can generate bespoke item visualizations that show just the right amount of information to the user. Lastly, we can add interactivity to our applications that help users navigate the data intuitively and find answers to the questions they have quickly. So, when should we use what? No-code tools, low-code? And when should we be implementing an application using traditional coding? There's no generic answer that will fit all use cases, but I hope that in my talk I could give you some of the ideas. There are definitely situations where no-code tools can be of great help. Often they require little to no setup and you get results very quickly. This comes at a usability cost though, because most of the time this stays a generic application with a generic user interface. With a little bit of coding and with the help of some low-code techniques, you can create a much more customized user experience that better suits your use cases. In many cases, this is what you should aim for. If you know that you have very specific requirements, I still believe that creating a bespoke visualization app using code will give you the best results. And for a lot of projects, this may very well be the only feasible alternative. As this was a virtual talk, I cannot answer your questions directly in this session, unfortunately. However, as I said, you can learn more about our products from our website, wireworks.com, or contact me and the team either via virtual booth or the usual channels. We're happy to discuss with you all of your questions around the visualization and the presentation of graphs, diagrams, and networks. I was asked to answer a few of the most frequently asked questions, so here we go. What platforms and languages does Wi-Fi support? Wi-Fi is actually a family of programming libraries for various platforms. We support the web platform, which I was using in this talk, and the JavaScript or TypeScript web component integrates well with all major web technologies and all well-behaved UI frameworks. Diagram visualizations can be integrated in virtually any existing app or dashboard, and of course, you can create new visualization apps from scratch. We also support desktop applications for Java, which is Swing and JavaFX, and C# on the .NET platform, which would be Windows Forms and WPF. A version for Python is in the making, and there are some early experiments with a native C++ API. Please contact us for more details if you want to learn more. The question about the performance is a very tricky one, and there's no generic answer, unfortunately. Performance is a wide field and covers visualization performance during interactivity, mostly measured with frames per second, but also graph loading, automatic graph layout, and graph analysis algorithms, which Wi-Fi also implements. For Wi-Fi for HTML, for example, although we support WebGL and HTML canvas in addition to the SVG rendering, and it is thus possible to render tens of thousands of elements on the screen, some of the algorithms will take a long time to finish if run on these input graphs. How long exactly depends on various factors: the size and the structure of the input graph, the algorithms used, and their configuration. And also depends on your expectations. While for some apps it's perfectly acceptable to wait 10 seconds for a huge graph to lay out and display, in some other applications that would be a no-go. However, usually we recommend our customers to not even try to confront their users with graphs of that size. While diagrams with tens of thousands of nodes often can look really pretty, they are also mostly useless and for real-world questions, not helpful at all. Users should not need to look at an artistic visualization and depend on their cognitive capabilities in order to find interesting aspects and their answers in the diagram. Instead, the app should ideally come up with a small diagram that only shows the relevant information that the user was looking for. And that usually means a low 2-digit number of elements on the screen. And of course, for these sizes, even on the poorest hardware, performance should never become an issue. Wi-Fi provides many different strategies and graph analysis algorithms to help you keep the number of elements in the diagrams low. This gives the best performance and, more importantly, a superior user experience. And the last question, of course, is about the cost. The library is available with a perpetual and royalty-free licensing scheme, and the price depends mostly on the number of software developers that implement the application. You can find our price lists online, which can contain the prices for the different platforms and licensing variants. If you don't want to go through the price list, we can help you finding with the correct item in the chat. And if you're currently working on a project that helps in the fight against the pandemic, you might even be eligible for a free license. So for more questions and answers, please do contact us virtually. I finished early, so you could use the remaining few minutes to visit our virtual booth and ask your questions in the chat. Thank you for watching, and as we say, always happy diagramming with Wi-Files and Neo4j. Bye.